Okay, welcome everyone. So around the globe, so it could be good afternoon, good morning, good evening, or in my case, it's middle of the night, so I stayed up. I'm in Sydney time zone. Unfortunately, I'm not in Sydney due to the COVID situation. Although you see that picture here, I've been in Sydney at the beginning of the year before the whole COVID outbreak started. So I'm going to talk about how systems communicate with each other, leveraging, the Azure Integration Services. So this is going to be my talk. I work for Coded in the Netherlands. So I'm another Dutchie on the agenda today, and I'll talk about, integration predominantly with regards to, having system integrate. So the story will be a little bit about technology, use cases, best practices, a little bit Power Automate, how that fits in, architecture, some takeaways. So let's have a look. So the first acronym I want to use is when it comes to languages, right? So there's a biblical story, at least some explanation of why we speak in all kinds of language. So back in the day, and this is a painting from Peter van Breugel. So he lived in the 16th century in the Netherlands. So he was a painter, or actually in Flanders, which is now called Belgium. And basically the Babylonians wanted to show off the fact that, hey, we can reach God by getting towards, heaven. And God was not so impressed by this, and he basically disrupted them by letting them speak other languages, and then they never were able to finish the tower. So, and with that, if you look at how systems could communicate with each other, using a similar acronym, we can have all kinds of systems these days. Back in the old days, we have SAP, Oracle, those types of systems you integrate with. But, nowadays with all kinds of SaaS applications, you see, proliferation of all these type of, systems that basically could, potentially communicate with each other. So that said, look a little bit like the application landscapes. Also, where I'm coming from is, on-prem world where you have mainframes, SAP, Oracle, that kind of systems talking to each other, towards when cloud came, when, systems were also talking to systems, software as a service services you find in the cloud. So you get a little bit of a hybrid scenario as well. And tomorrow, at least where we're heading to, where we are already today, you could even have all kinds of SaaS applications talking to each other, or devices, mobile, etc. So these are kind of, although it says yesterday, today, and tomorrow, basically you have these worlds today. So how do we get there? So, when I started going into IT, you had this box product called BizTalk Server, which enables you to do this communication between systems on-prem. And of course, shortly after, a couple of years later, 2008, Microsoft Azure was launched, and it was announced. And kind of Microsoft's always looking into the fact that, hey, we want these kind of capabilities and system communication also in the cloud. So they started on this journey, getting some of these services out. So they started out with AIE EDI labs, then something like BizTalk Services that eventually didn't work out. So they stepped on something new, which was called Logic Apps, which became, GA in 2016. So then having similar integration capabilities, allowing system communication, leveraging cloud technology. So if you then look again to that integration landscape, so if yesterday you had kind of this brokered product called BizTalk Server, and then going to a hybrid world where you have API management, logic app, and that stuff, towards some, even with matching capability, API management or logic app, allowing you to completely do cloud native type of integrations or communications between systems. So that said, let's have a look a little bit about the integration tag. As shown before, now our toolset basically consists of what's called Azure Integration Services. So these are basically a collection of services and capability that are available in the cloud today. So instead of having a box product where you have all those capabilities and features inside one product, now you have several services providing you the capabilities of system communication. So there could be a logic app where you have these workflows and connectors, basically supporting your business process. You have a service bus or an event grid. So service bus doing, allowing you to do enterprise messaging, and event grid, one of the latest addition to Azure, where you can centrally manage events and supporting more an event type of integration or communication between systems. And you got API management, allowing you to connect to APIs or securely expose some of the APIs. This will become more apparent when I'll talk some of the solution architecture and real use cases. So I'll go a little bit into the tech to give you a little bit perspective of what this tech does and how this relates to system communication and integration. So one of the things is logic apps, allowing you to connect to all kinds of systems, whether they're on-prem through an on-premise data gateway, or either connecting to all kinds of API, leveraging API management, or some of the connectors that are available inside logic app itself. So this allows you to enable system communication or support business processes, or even support on-prem integration through hybrid type of scenarios. And you can even tap into social media, but also into cognitive services to build some other type of applications. The big deal about Logic App is that it has all kinds of connectors. So back in the day with the box product, you had BizDoc Server with what's called adapters, and now you have the Logic App capability inside the cloud, offering all kinds of connectors. So one system could easily talk to another system using a Logic App, creating or using those connectors. And there are like hundreds out-of-the-box connectors available. If a connector is not available, there's even the capability of creating your custom connector and also supporting connectivity towards systems and reuse that connector to multiple Logic apps. And the other way to have connections to other systems is through the API management, having gateways in and outside of systems. And basically this sits around the borders of your systems if you want to use them as such. So what's important about Logic App is its runtime. And I'll get into this, is that it has a resource provider which basically looks into your definition, how you created your flow, together with a runtime that distributes those tasks that are depicted in that flow, combined with a connection manager and a connector runtime, supporting those connectors and connectivity to those systems. So that said, let's say this is, I'm not going to show the design. This is just, let's say you design something like this. One system just pushes message to a service bus. This Logic App, through its service bus connector, picks up those messages. Let's say this is a message, has multiple records, tries to insert that into a SQL database, and then completes the message on that queue. So when you save, you basically have a workflow definition. That workflow definition is being interpreted that it has basically many tasks. So one of the tasks is a trigger task that when the message enters a queue, it basically kicks off that workflow and runs it through what's called workflow orchestrator. So that workflow orchestrator basically runs the definition that's been broken down by the resource provider. So there's going to be a for each, there's going to be multiple executions of inserts into the database using the SQL connector. And once that's done, it will complete the message. And all these tasks are done in parallel. So there's no thread management whatsoever. And then, of course, your workflow is complete. And what's important about it is it's all task driven. So the fact is that, this is all chunked up in task. And then, inside a data center where you basically use your Logic App, this is being executed at least once, and if not, then it will, when it has to deal with these transition type of errors, DNS errors, or systems that are down throttling, then it'll do some retry as well. And this is pretty important when it comes to system communication. That said, so this is kind of a shared runtime. What I talked about is how the runtime works when you just leverage it out of the box and using the page model. Then again, if you don't want to share your compute with others, you want to have your isolated environment, then you can have something which is called an integration service environment, which is similar to what you can have with an app service. If you want to add dedicated compute through the app services, you can have this application service environment for yourself, similar to integration service environment. So you get your own Logic App runtime and your own connector runtime, and it's combined with integration with the express routes, and there are some enterprise capabilities around it. You can even tap into the on-premise resources using VNet and such. And recently during Ignite, it was also announced that Microsoft now has Logic Apps in preview, running them stateless within the function runtime. So the function runtime is now also available for logic apps. So you can either have your shared runtime, you can either have it dedicated, or you can even have it self-hosted or containerized, which means that you can also run not only your functions, but also your integration on-prem and leveraging the connectors. You can even run it multi-cloud or even on edge. And this is something my colleague written about in his blog post, and I definitely encourage you to look at it too, is that basically running that logic apps anywhere is kind of a game changer. So it basically opens up a lot of possibilities of running your workflow and integrations on many different, let's say, platform or hosting environments. Okay, so let's look at some of the other tags. So I talked a bit about logic app connectivity, similar to what you find in a box product. Then there's some other capabilities that all are, are part of this Azure Integration Services. So one is the managed service for queuing, which is called the Service Bus. And basically it can be, a backbone for all kinds of cloud solutions, can be something that supports hybrid solutions or even platform agnostic, because the queue supports HTTP, AMQP compliance and so forth. So basically allows you to do some asynchronous messaging and communication with systems. And this capability comparatively, so you also have within the storage account, you have Azure queues, but they lack, for instance, like first in, first out, duplication or transaction behavior. This is all available inside the service bus. And it basically consists of a couple of components. So you got relay, queues, and topics and subscriptions. So if you look at the service bus, it gives you the ability to do direct communication through an outbound connection. So basically you have your service hosted up, running, basically creates an outbound connection, and then through another outbound connection, and then what's called a rendezvous, these things come together. So you can have this outbound connectivity connection, leveraging that to do this direct communication. So you also find this back in the on-premise data gateway, which you can use in combination with Power BI. So you can have Power BI tap into resources on-prem. So as soon as you install that, on-premise data gateway, you will see that on the backbone, in the background, basically it creates a service bus relay. The other component is a service bus queue, allowing you to push message on a queue and then have something take them off. So this can be easy for decoupling, but also maybe for store and forward. Your messages can reside based on the time to live multiple days, but also can help in load leveling and balancing as such. There can also be multiple subscribers or receivers based on the load, or you have multiple senders as well without any impact. And then the other thing is something which is called kind of an Uber queue, which allows you to send a message, which then subsequently can have multiple subscribers and multiple systems that take that message on based on a filter set on the message, meaning that a message being sent is called a brokered message containing a context with key value pairs, which can be subsequently be used in those rule-based subscriptions. So those are kind of the capabilities that the service bus offers. And then next to a model where you can push messages and pull them on directly or later on, you have something which is called Event Grid. So this enables you to do event-driven reactive programming in a way that messages are being pushed and then straight away are being picked up by one or multiple subscribers. So this could be consumption of Azure or even non-Azure resources. Like I said, you can do some reactive programming based on an event happens, basically being pushed to a topic. This is what it's called, basically an event grid topic. And then you can have multiple subscribers handling those events on the way they need to handle it. And I have some example of that as well. So looking at Event Grid, basically it's baked in quite some of the services in Azure, not all of them, but many of them. And next to it, you can even push your own events if you want to Event Grid or even cloud events. So I'll get to that as well. And then on the other end, you can have multiple types of handlers, could be functions, could be a logic app, could be push to event grid or storage queues, or could be some other applications using, for instance, a webhook mechanism. So basically what this service enables within the Azure Integration Services is that it allows you to manage events in one place. So you have a topic which is kind of the source, let's say that's a storage account. Then you basically, when you create this type of subscription, then it's okay, the source is a storage account. The event type is when a blob is created, for instance, depending on what the source offers. Then you can route those events using some kind of subscriber type, whether that be a webhook. In most of the case, it is a webhook, and you can enable some filtering as well, meaning that either, for instance, in a storage account, you can point to which type of container it is, but also what type of blob it is. Let's say it's JPEG, and you can basically then get those events and start reacting upon them in your event handler. So the concepts are pretty similar, pretty basic. An event has happened, and this happens within what's called an event publisher. So that's where those events take place. The topics is where the publishers basically send their events to, and then there's one or multiple event subscriptions to where handlers will receive those events and subsequently react upon those. There are two types of schema. So you either have the proprietary event grid schema, which is on the left-hand side, or you have something what's called a cloud event, and there's something initiative by the CNCF to get basically more a cloud standard, or let's say not a cloud standard, a industry standard for events. And then finally, within NoTech and within my toolbox of Azure Integration Services, you find API management. So that allows you to publish endpoints as a proxy inside a management tool, as providing some kind of a gateway. So you can set up a facade for your services like a Logic app, APIs hosted in an API, an in-app service, or it could even be functions. So that API management basically sits in the middle of one end, the APIs being created by developers or are available and then are being set up using an Azure portal inside the gateway. And then on the other end, you have your consumers that can use your services. So on one end, you can leverage or use API management to secure your endpoints. So this could be an endpoint of an HTTP function, but also HTTP logic app, for instance. You can leverage and use it to analyze the traffic towards your APIs and such, and you can do monetization, but that's a little bit besides the point when it comes to integration, having, when systems need to communicate or exchange data. And on the other end, you can, when you're a developer, you can start learning about, how the API functions and works and try it out. Usually when it deals to integration, it's just like setting up if the contracts are straight and if, one system can ingest the data from another system or vice versa. So basically, API management sits in the middle as a gateway, as an intermediate between a service on the back end, and basically the API inside API management is kind of a representation of that API and its operations as a facade, and then it's being exposed to other applications or systems. So it can have one endpoint on one end, that's an endpoint, where it's hosted, but then you can translate it to an endpoint based on the API management instance. Usually that's Azure API Net, and then in front of it, it's the name you provide for your API management instance, and then slash, for instance, your API. And basically, the API definition you create can be a representation of one or multiple exposed logic apps, or at least HTTP triggered logic apps or function and so forth. So you can even make a composite services type of thing or an API which points to or reference one or multiple operations of even multiple functions or logic apps. And then within your API, you define within API management, you create basically policies, allowing you to validate tokens when it comes to security, rate limiting, etc. So basically, when you look at the designer, when you basically specify that API, which can be a representation of one API and multiple operations sitting in your backend, or it could be multiple logic apps or whatsoever, which kickstarts a process. You have a few sections. You have your inbound processing, then it goes to your backend, and then you have the outbound processing. So this is where you basically place the policies, or they could even be on the on error. So that's another one section where you can also place policies when it regards to errors that happen within your policies, or giving a user-friendly error back. Those policies can be set on a global instance level, on a product level. A product can be a grouping of several APIs. This is more like a functional grouping, and then you have APIs with its operations. So there could be cross-origin logging purposes globally. You can do some rate and quotas on all the APIs within a product. You can enforce a Java validation token taking place policy that accounts for all the operation, and then you can have something like caching, body, and such. So those are the policies that you can set on different levels. So when you execute, you maybe provide a key, so a subscription key that comes with a product. So when a subscription key can be used for authorization purposes, it has to be given inside the header to provide you access to APIs, for instance. And then you got your API and you got your operation. Okay, so this is just a tag. This is inside my Azure Integration Services components that I need to ensure, or at least create or leverage them to have systems and exchange data and communicate. Then I want to dive into you with solution architecture. So I have this layered kind of diagram that shows you different aspects of a solution architecture that we usually use, me and my colleagues, when it comes to integrations. So you got your APIs, integration, and messaging. So this is where you can fit in those Azure Integration Services. Then you got security, automation, you got some infrastructure, and you got some auditing and operations. So within those layers, you find responsibilities when regards to building up your solution. So you got your integration with workflow connectors, you got source control, you got security and access control, you got some networking aspects. Hosting falls under that umbrella a little bit well if you look at infrastructure. And then on the operations side, you got reporting, monitoring, and extensibility. And then you can plot in some of the technology. So you find some of the Azure Integration Services plotted here as well. You find your API management and APIs, your integration with Logic App, and the messaging capability using Service Bus and Event Grid. Then you got your DevOps for automation. And for security, you have things like Active Directory, Key Vault, Security Center. Infrastructure is networking, a portal. And on the monitoring side, you got Azure Monitor, OMS, or Power BI. So these are all kinds of components that you can use for building up your solution when it comes to communication between systems. So let's dive into some real-world cases. So this picture basically shows data being pushed from one end, so that's from the right end, from the left-hand side, from a warehouse management system, or could be multiple systems, to the box product, which is BizTalk, which basically maps those workloads to a canonical data type of model, pushes them through API management, which basically secures the endpoint of an HTTP triggered logic app where that payload enters, and subsequently is being pushed out to Dynamics 365. Dynamics and operations, also through an HTTP endpoint, which is also, again, put in that API management middle layer as a proxy using OAuth as technology for security. And then another mapping is being taken place inside that inbound policy, or at least when it enters, when it goes towards the backend, where another transformation will take place from the canonical data model to a request message, or at least the data contract, which adheres to what Dynamics 365 wants to receive. So you have a box product, basically still communicating with them, so on-premise systems, but then pushing data out towards the Dynamics 365, which subsequently processes that data once it enters that system. Now let's have a look at a more cloud integration scenario. So this is for a customer that has several SaaS systems. So that is Salesforce, that's AFAS, that's ServiceNow. And here I got depicted one of the integration where Salesforce basically sends out an event when some entity is being updated. This could be, for instance, a new lead that needs to go to ServiceNow to become actually, so it's a prospect becoming an actual order, that kind of process. So the event's being pushed again towards a Logic App HTTP, that's HTTP triggered. That endpoint is being secured through API management. That event is subsequently mapped towards an event grid proprietary schema and then being pushed to the event grid topic. Subsequently, there's a logic app handler. So this is kind of the push-push model where the logic app, where the event comes into the logic app, and that logic app basically then looks at the event and there's some data in there allowing him to, okay, I'm going to react upon this and I'm going to actually get more details of this prospect. So we'll go through the same API management instance all the way up to Salesforce. Then what you see here is another inbound policy. What it first does, and this is a policy that adheres to all the operations of the Salesforce API, is that it will authenticate first, it will a token back, and that token will be pushed into each of the operations going forward to that Salesforce API. So in this way, it will get the details. The details will come back to that API management or the API and API management, and then it will do this transformation to a canonical data model again, using the set body policy where a liquid transformation will take place, and this data will enter into the logic app. Then subsequently, this data is being pushed towards the ServiceNow endpoint, again secured through API management using OAuth. And then another mapping will take place from a canonical data model towards the request object or data contract that ServiceNow requires. So this is how this scenario works. And when it comes to communication of systems with each other, even though, these similar with languages, there are all kinds of languages. If we want to communicate, we either have to speak the same language or there has to be some translation. And when it comes to whether it's a hybrid integration or on-prem integration or even, an integration, in the cloud, it's that the magic basically sits in this transformation. So the tech that you can use is either those API management policies, which you find within API management. Could be that you leverage a function, for instance, to doing your mapping, leveraging XSLT libraries or whatsoever, or you can use something which is called an integration account, which is a separate service inside the Azure platform, allowing you to upload schemas, maps, etc., and allowing that component, or at least have that component do the transformation. So there's different type of tech supporting that transformation, which is pretty critical when having systems communicate. And this can either be the formats, you can have either XML that leverages XSLT, you can have JSON mapping using Liquid templates, or you can have something like custom with just .NET mapping if you like. The other aspects when it comes to, when systems communicate with each other, that there are also some practices you need to think about when building those type of solutions. So one, of course, being loose coupling. You can either leverage the event grid or the service bus, queue or topic. The other thing, of course, is with your mapping that you map from one contract to a canonical data model, from canonical data to your target system, basically giving you more flexibility and agility. The other thing resides to monitoring, because when you have this system integration build up and have those systems communicate with each other, then it can be that it's a pretty important process you're supporting, so the data has to be pushed in a timely manner to another system, and you want to have a grip on top of it by using monitoring. Either it's technical monitoring or functional monitoring. The other aspect could be that you, within systems, you more think about when they support this, more geared towards an event-driven system, which is more low cost, gives you more real-time messaging and less latency, depending if your architecture can support this. The other thing nowadays with cloud is that with on-prem, you have this licensing, when you talk about the box products and such, and service and all that stuff had to be cured. So that's like upfront cost, capital expenditure. And now, of course, with cloud, even when you do this system integration, you have to think about costs as well. And you probably have multiple environments where you do your integration. So you have to look at the cost of each of those environments. The other thing that's important is with applying versioning on top of your APIs, which reside in your API management, but also the versioning of your logic app if necessary. The other aspect that's important is the governance. One fact is that if it's sensitive data, you have to think about governance aspects, but also who can access what type of system, etc. And last but not least, when it comes to deploying your solutions in the cloud, you have to apply automation, or at least automate as much as possible. Given those aspects and those best practices, let's again revisit some of the things I talked about earlier. So when it comes to event-driven, there's some other aspects you have to think about. So if you have those systems, you have an on end, you have your Salesforce system, which of course has an admin, and on the other end, you have your ServiceNow system, which also has an admin, and then you, together with your colleagues building up this system and monitoring it, also have access to, in this case, the cloud. So from a governance and operational perspective, these are important things to have to think about in this type of solution. Building up this solution with the tech is pretty straightforward, but then again, you have to think about those aspects as well. You might be, as a consultant building up the solution, talking to the Salesforce and to the ServiceNow admins, how you can connect to those systems and what type of data they expecting or transmitting basically, or how the data exchange has to take place. Then from the cloud perspective, you see some other stuff I've drawn out here. And when it comes to API management, you have to think about security aspects, subscription keys, the way you define your APIs and how you apply your policies. Then with Event Grid basically has this, when as soon as you push a message or an event on an Event Grid topic, Event Grid will try to deliver that message at least once, and if not, will through an exponential backup try to push that message towards the subscriber. If not, then you can explicitly set that lettering on those topic subscriptions. So it's definitely something you have to think about as well. If the events cannot somehow be delivered, either have those mechanisms in place where you have some monitoring or catch those as well. When it comes to API management, for instance, you have to think about supporting security mechanisms, for instance, OAuth, but also role-based access. The other thing you can think about is key vault when it comes to securing backends, using HTTPS or SSL, and then it's a good place to store your certificates. And the other thing in general, you have to look at some of the alerts and metrics. So Logic App, for instance, has all kinds of metrics where you can put alerts on. Let's say run has failed, which is one of the metrics of Logic App. So you can set an alert on that if that exceeds 0. There's something we put in place well. That's more the technical monitoring. And then functional depends on how you want to do that. Is basically you centralize logging of all of these steps to one central place and put a dashboard on top of it. The other thing is when you build up these solutions and you apply some of the best practice that you have multiple environments, multiple subscriptions, that you have to look at the cost as well. So each of those environments, we put on some budgets and alerts when it comes to cost. And then on the lower end, from a developer perspective, you as a developer are building templates to have your consistent infrastructure on all these subscriptions. So that's one end, what you will do. The other thing would be API definitions, which you can extract through Cloud Explorer using Visual Studio Code. So you have those templates similar to Logic App. So you basically extract those templates and then push them into repro. And then, for your infrastructure, your API definition, you use your YAML pipeline so you can have those deployments. Similarly, even for hybrid solutions, the same thing accounts. You have various admins. You have an admin on the Dynamics 365 side. You have your Azure admin. You have the BizTalk server. Again, you have to interact with these people, setting up the contract state and see how the data enters a system or has to come out of a system, doing some of the mappings. What you see depicted here, for instance, also how for this type of solution, we set up functional monitoring as well, where some of these steps inside, this solution is basically pushing data, metadata out to a service bus where there's a Logic App behind it, pushing all that metadata into a Cosmos database document store, which is subsequently being indexed, and those endpoints of those search are being consumed inside the dashboards, giving you the searchability of the steps from data going from A all the way to B. Again, some of the other aspects with regards to a hybrid solution. Similarly, Azure monitoring with alerts and metrics set on the Logic App. And when it comes to API management, you have to look at the subscription APIs, policies, and such. So those are the things that set up. And on the other thing, again, you have to think about automation as well. So the automation, again, of your Azure infrastructure over multiple subscriptions. And then again, also, in this case of the box product, there's a deployment framework available, allowing you to do some packaging, push them in a repro, and then again, you have some automated deployment also from, in this case, your BizTalk artifacts. So again, automation applies here as well. Okay, then I want to talk a little bit, dive into the other kind of tech, which is called Power Automate. So this is part of the Power Platform, and that also provides some capability when it comes to system integration, or one system exchanging potentially data with another system. So there's a capability inside Power Automate, which is called robotic process automation, basically allowing you to do, when the system is completely closed, so when there's no API whatsoever, you can still extract some of the data using this technology. So you can record some of the steps, automate those, and then even play them back or push that data out to, for instance, Azure. So what you would do is you would use the UI flow connector available in Power BI and use that to basically set up this screenscaping type. So under the hood is Selenium that's being used. So you launch a recorder, you record your steps, and then you build out your flow. And then potentially the data you push, get out of a system that's one end completely closed, but you still, you're able to get data out using this technology. Then you could process this data. So this is a small animation. So this basically shows an old WinAN automation tool where some of the energy prices are being scraped off and written into Excel. And basically you can do something similar, getting that data out and push that into, let's say, a storage account, into a container, which subsequently, you have this event called blob created, which then pushes that event gets into an event grid, and on the other end you have your handler, which can then download up the data from a storage account, and then you can further leverage, or you can further process that data as well, or push that data out to another system. So altogether, Power Automate really connects well with Azure Functions. So you can even within a Power Automate leverage some of the Azure functions, which subsequently could, for instance, talk to other systems, or you can even push the Power Automate you created that flow into a Logic app to get more control and further build out your flow and your integration with other systems if necessary. And even through a Logic app, you, for instance, can call out to a function or vice versa. Okay, so we have the integration tech. We have, there's tons of types of scenarios that, you can build up with using Azure Integration Services, which are the Event Grid, Service Bus, API Management, and Logic apps, and even Power Automate is such a way which is complementary to those Azure Integration Services. But what do analysts say? So this is more from a marketing perspective. I always find this interesting. If you look, for instance, into the Gartner quadrant with regards to integration platform from a service, so this is where Logic App, for instance, falls under. Logic App became GA in 2016, and the subsequent year it was already in the visionary quadrant, and then subsequently 3 years in a row now is being seen as one of the leaders. So within this market, there's multiple products that can support integration and facilitate communication between systems. But Microsoft with Logic App is one of them, and they're now currently also seen as, or currently they're already seen for the last couple of years as one of the important facilitators of this time of technology. That said, then also API management recently also entered the leader quadrant. So this happened this year, so this was depicted in this report. Now, Logic App and API management are basically seen in this quadrant. So that means that it's serious tech, and it's being seen as such by also analysts. So this means that this technology really suitable for your integration with our systems. And there are other cloud platforms like AWS and Google that do not offer a complete set of components supporting some of the scenarios I showed you. They do not have all those capabilities on board. They have subsequently competitive solutions when it comes solely to API management or Logic App. When it comes to a complete platform, they're just like, ahead of the pack. And then it comes even to low code. Again, Microsoft competes with some of the other technology. This is more the offering from the Power Platform, and this is Power Automate, Power Apps. And then again, you find this technology also in the leader quadrant. So this is more from a market aspect. Gartner sees them as really technologies that can compete with other serious contenders as well. Okay, let's look at some of the key takeaways. So Azure offers quite some technology also when it comes to integration, and you just basically, when you look at those components and some of the hosting options, etc., you just have to look to your requirements. Well, which components fits best when it comes to an overall solution. I've talked about Power Automate, Logic Apps. You got like Azure Functions, which can be helpful in integration solution as well. But they're not competing technologies. Neither are Event Grid or Software Plus. I want to stress this out. So there's not like one versus the other. It is when it comes to competitive solutions, other cloud platforms, or standalone products. But these components all by itself are just complementary and help you build up your solution to have this system integration. And then the other thing I want to stress out, so I always shown you in those real world case pictures that you have to apply those best practice when it comes to governance, versioning, etc. And something you can really leverage is something what's called the Azure Well Architected Framework, which recently released, giving you guidance and best practices around, operation of excellence, so how you set up your monitoring and cost management when it comes to governance, but also when it comes to automation and DevOps. So that's also why I mentioned those best practices earlier on, also when it comes to those real world scenarios. So you have to cater all those things in. But those are available also through this framework, which is recently being released. Okay, so there's some resources you can explore when it comes to system integration. So I've listed them here. Azure Well Architect Framework, for instance, very interesting, also available for Learn. So you can really learn how to apply those practices. Integration patterns you can find, tons of material that you can use. Okay, so I would say thanks for attending my session. Here's some of my details. So you can reach out for LinkedIn, Twitter, email. If a question doesn't pop up right now, but later on, you can always contact me. And the slides that I've shown you and everything is available through this link. You can click on that and you can find those. I will later reach out in Twitter as well, where you can find those. And yeah, this is about my talk, and I think we'll probably have some time for QA. So let's look at the Slack channel, or let's have a look at the. Okay. So can we reuse the same connectors if we're running on-prem with AKS? So yes, this is available. They're working on this well, so you can leverage the similar type of connectors as well within those containers. It's limited, as Elliot points out. Do note that these connectors, some of them are also available in Power Automate, not all of them. So there's some distinction. The product group in Microsoft responsible for most of the connectors, build connectors for either Logic App and or Power Automate. And so many people say thank you, great session, thank you. Well, I'd like to thank you as well. So yeah, if there's, let's see, a bit late, so or early, you'd say, but I don't see any other questions. Oh, someone asked, how do you pronounce my name? Steef-Jan, or you can say Steef or Steph or whichever you like. So it's a double name. So one of my grandpas was called Steef and the other granddad was called Jan. So they basically made a combined name out of it. So If not, then it's coffee time for some, maybe. Okay. Well, thanks again. Yeah, this is how it is.